Okay, so we've got a new episode of Legends and Leaders, and today it's great to have someone here who's really pioneering an incredible new area of, autonomous delivery, having these robots go around and, deliver stuff more affordably for people, more efficiently. And I mean, they're now in so many different incredible cities. You see them, riding around, and you're like, wow, this is the future. The future is here. So I'm excited to have you here and to get into all that you've built.
Thanks for having me. I love that. The future is here is my favorite statement about robots.
Yes. So just kind of like going back into your origins, like were you always fascinated by robotics? Were you like a sci-fi kind of guy growing up? Like how did you get interested in this space and then what made you want to turn it into like something you actually pursued in life?
You know, it actually started for me when the first time I heard about, Bill Gates and Microsoft starting a company out of his dad's garage and bringing computers to every household. I remember my dad telling me this on a drive. And I was living in Iran, so I was actually not in the media ecosystem that we have here. I have never watched Star Wars, which a lot of people fault me for, but my imagination immediately went to, okay, what is the next big thing? What is, if the computers are in every home, what is the next thing that's going to have to be in every home? And of course, that's robots. So that was something I wanted to do and start a company making robots and bring them to every home since I was basically a teenager living in Iran and didn't know any better about any of those things of starting a company or making robots. But the dream kind of came to life at that point.
Hmm. So when did you come to the US? Like how old were you?
Well, I actually first moved to Canada when I was 19 and moved to the US, I don't know, 2016. So been about 10 years.
Mhm. And when did the company launch like for you during that time? Like were you thinking about the idea, 10 years ago or was it something much more recent?
I've been fascinated with robots ever since when I was in undergrad at UBC in Canada. I actually started working on the DARPA Challenge competition. So the self-driving cars. That's how a lot of really this whole race began back in 2005, I think. So 2004-5. That's the time frame. And I worked on a little-known sensor at the time called LiDAR. Which was this really industrial sensor from a German company and really expensive. And that's when it started to be adopted for self-driving cars. It became obvious that it's kind of an unlock because you can understand the 3D geometry around you much better, keeping in mind that at the time AI wasn't very good. So looking at a camera didn't really tell you much about the environment. You just saw a bunch of colors. But with LiDAR, you can actually see forms and you can understand if something is in front of you. So I was working on this back in 2005, basically, or 2004 even, before anyone knew about that this little known sensor called LiDAR. And then, I went on to start a few companies, usually in the hardware space, always in the AI space, partly because after graduation, I decided that, robotics wasn't quite ready for prime time. And this is, again, we're going back to, 2008, 2009, 2006, when I finished my undergrad, and then 2011, when I finished my PhD. So I didn't think the timing was right. But then when I came to the US, I met with the founders of Postmates. They were interested in my company at the time, which was also in the AI space. And that's when this new idea was born, which is, okay, robots on a sidewalk delivering food. It makes sense. The time is right. We should get going.
Mhm. Were there certain like things technology wise that like you felt like the time was right? Like what really made you think the time was right? Was it just like the funding was there, or like what pushed you to say, hey, now I can do this?
I think one of the biggest unlocks was the domain, actually. It was the fact that suddenly you had this incredible demand and growth in on-demand delivery. So you can, anybody can press a button and something would show up. But now it's being delivered in a car, as we like to say, why move 2-pound burritos in 2-ton cars? The fact is, when you're moving things in a short distance of a couple of miles, you don't need a 2-ton vehicle moving at, 50, 60 miles an hour. Once you simplify the problem to a smaller form factor, less weight, less speed, you significantly decrease the risk. So the kinetic energy in a car is 3,000 times more than a robot of our size. And kinetic energy is where all the risk is like hitting something. That's the transfer of the kinetic energy that causes injury or possibly even kills people. But if you have thousands of times less kinetic energy, you don't have that problem anymore, right? So the technology that existed that wasn't quite there for the cars to be autonomous could actually work for the robots. And that was our thesis. And I think it's generally proven to be right.
Mhm. Yeah, no, it makes sense. Like just building out the first robot, like how did you finance that? How did you get that off the ground? And did it really work well, or was it just like kind of something that was proof of concept enough to get more funding?
Oh, it's been 8.5 years. So it started with really basic proof of concepts. So Postmates is where this began. When I joined
Mhm.
Postmates through that acquisition in 2017, we had some really interesting insights because we could look at the one of the largest delivery platforms in the country, look at the raw data of all the demand for deliveries and what do they look like, and we could see that most of them are like a couple of miles at most, which means a robot can do it. So that's where everything began. And within a week, like literally, we started on a Monday. By Friday, we had a robot on the sidewalk, but it wasn't really very smart. It was being remotely driven.
Mhm.
It was a bunch of Amazon parts that we had purchased. But the idea was we should get something out so we can see what it's like to have a robot moving around on a sidewalk. And we learned so much from moving so fast by having something that we can actually experience the end product very quickly, and it informed a lot of decisions. So within, I think, 9 months, we had done more than 1,000 actual customer deliveries with our new fleet of little kind of prototype robots. And a couple of years after that, we had our robots operating in Los Angeles during COVID, and the rest is history. Now we have more than 1,000 robots today. By the end of the year, 2,000 robots. It's one of the largest autonomous fleets in any urban environment in the world.
How did you make it autonomous? Like what went into getting that technology right? It's something the car industry still hasn't finalized yet.
Well, a lot of the technology is very similar. It's you need to see the world. You need to then take those sensor information and really understand the world, and then you need to tell your robot what to do. And the lidar sensor, the better computers that like Nvidia is providing, all that is really very similar to what you see in the cars. But the difference is that we are not moving as fast, and we can stop at any time and ask a human to help the robot. So think about it this way: if you're on a sidewalk, if you're on a street and you get to an intersection and you need to decide is it safe to cross or not based on what the traffic signal tells you. Well, if you stop on a green, it's bad, and if you
Mhm.
cross on a red, it's also bad. And you really don't have a chance to just say, I'm gonna stop right now and ask someone for help. That's not an option, because again, stopping on a green is dangerous. On a sidewalk, we don't have that problem. If we stop on a green, nothing bad happens because we are not blocking
Mhm.
traffic, we are not moving that fast. Crossing on a red would not be great. So we have models that are super sensitive to make sure we don't ever cross on a red. And that's much easier to build. The orders of magnitude less complex to have a model that's really sensitive to one thing, but it can tolerate the fault in the other dimension. And basically our way of thinking, our mental framework was, when we are on a sidewalk, we can have a human do a lot of work at first, and our job is to automate their work. So the very first delivery we did was fully teleoperated. Someone was controlling the robot. And our engineers would sit in that room and watch what that person was doing, and then decide what is the first thing we should automate that reduces the most amount of workload the fastest. So that's the journey of kind of going from a robot that was purely human operated remotely to a robot that now is primarily doing the driving itself, because we have slowly but steadily gotten rid of all that workload for the remote operators.
Mhm. Well, why go the route of partnerships with DoorDash, with Uber, instead of, you could do building your own app and kind of be bringing people there. I mean, both could be fine, but I mean, it seems like the partnerships have been really crucial to the business. Like,
Yeah.
why focus on that so much?
I'm a bit of a data nerd, and it's something that I've always really, enjoyed doing. On a weekend, you'll find me just, playing with spreadsheets, even if it's not work. So what we did at the very beginning was we took the data from Postmates and we built some really cool like physical simulation models that would assume, okay, if we have 50 robots in this neighborhood and look at the demand from Postmates yesterday, what would have happened to these robots? What would they have basically done? And then we would simulate different scenarios like, hey, if we have robots that are dedicated to specific restaurants, or if we have robots that are deployed in a certain way where in the middle of the day they have to stop and get recharged, so that's a different robot design. So there's a lot of questions like how much battery life should a robot have, how should it be deployed, should it work with one restaurant at a time per robot, or should it work with all the rest? All those questions we could actually play with the data and see what the impact of that to the unit economics looks like. And one thing we learned, for example, is a robot should go all day on a single charge for the robot to make enough money. You don't want a robot sitting in the middle of a day for 4 hours, or a person having to drive to a robot to swap batteries. That's too expensive. Another thing we learned, it goes back to the question you just asked, which is, if we were to have robots dedicated to restaurants one by one, because we are going after one restaurant at a time, it would not get enough utilization to make the economics work. And we could really easily simulate this. Like, I remember I ran a scenario. What if we get 20 of the top chains in an area in Los Angeles where we were operating, and just assume we got them all under contract working with us? What would that look like? Well, it turns out those 20 chains would have really 40 restaurants in the area. And then I would put 50 robots, and I'm like, they're barely getting the utilization I need. But if I have those robots work for all the restaurants in the area, it's a night and day difference, because there's actually 1,000 restaurants there. It's not just 40. That's the key distinction. We realized really early that if you are basically going and signing one restaurant at a time, your utilization isn't going to work very well. But if you have a platform like Uber or DoorDash, or at the time Postmates, giving you access to everybody, you would get the utilization you need to really jumpstart the platform and have robots operating economically.
Yeah, the approach makes a lot of sense. And like from the utilization standpoint, it's just amazing like how the adoption from different cities has occurred. Like I think you've really done great with going at major cities and getting them to be willing to do this. How do you pitch them? Like how do you convince them to get on board? I was just recently in Miami and I saw some over there too. Like, is it just the economic benefit of it, the convenience of it, maybe less traffic in general? Like what does it take to get these cities to get on board?
Yeah, and look, it's actually you have to be cognizant of a lot of the fears and concerns that people have. Some rightfully so, some I think are more exaggerated. Like, people are talking about water usage in data centers, and there's some like really crazy ideas out there about what the reality really is. It's really just not a big deal the way people have kind of made it to be. And then there are other concerns around jobs or other things that are totally fair and we should be very mindful of. So look, I think what's important when you talk to cities or the public or just partners is to really explain the value proposition and help them understand why this thing needs to exist. And it actually doesn't take too much effort to explain the reasoning. The line that I shared earlier, why move 2-pound burritos in 2-ton cars? It generally is one of those kind of light bulb moments where people start to think, okay, yeah, this is kind of crazy the way we are doing things. Because think about it, it's a safety risk. Every time you get in your car to go buy a gallon of milk, you are actually accepting the risk of an accident, because that's a reality of driving around, and possibly even someone losing their lives. Like, no one who gets into a really bad accident knew when they got into a car, and probably what they were gonna do driving around wasn't important as the risk of that accident. And thankfully car accidents don't happen that often, but they do happen. So our job is to get less addicted to these 2-ton machines, because ultimately they're not really helping us move the gallon of milk. They're moving us safely and comfortably, right? So when you explain that to folks, I think it really rings a bell. And then of course on top of that is the fact that you can reduce congestion. Everybody wants to drive in streets that are less congested. It reduces emissions. We want to have greener cities, and it has an economic value for the restaurants, for the customers, and by the way, also for the workers in those cities, because we are going to create much higher quality jobs than a courier today moving one burrito at a time.
Yeah. So there's a lot of benefits for cities, very clearly, from what you just said. Um, so I think, yeah, I mean, you're just going to keep scaling it to more and more cities as you go. When I was recently in Miami, there was a Serve robot that needed help crossing the light. The light was like it was just right crossing. It needed like someone to click basically the walk button. I thought that was really fascinating because it asked me to do it and like shows you on the screen. I was like, wow, this is really interesting the way we're interacting with robots now. Like, how do you think about robot human interactions and like stuff like that? Like, why even have a feature like that?
Yeah, first of all, thank you for your service. Pressing the button. Look, there are certain things like the manual intersection buttons. We are working on automated solutions for those as well. But I do think that when you're operating in public environments, there's always going to be moments where there's an opportunity for some collaboration, and maybe today it's people helping robots, and in future hopefully the robots also helping people. There are all sorts of scenarios that we could be valuable for, and besides moving goods around, we do that today. By the way, we share data with cities about infrastructure issues, or where there is no curb cut, which is valuable for people on wheelchair or with disabilities. So, we are trying to make sure that we are also a good citizen helping other people. But at the end of the day, we've designed a robot to be easy to accept, by society. In fact, I think it's a missed opportunity if you don't. It's our imagination has been so ahead of us for so many years with robots. And for us to kind of make a really boring machine when we can have a little bit more fun and make it something really exciting. And I mean, just imagine a 4-year-old child seeing a robot for the first time. I've seen videos of this so many times with our robots, where a child kind of runs in front of a robot and is so curious and excited. And I mean, that's one of those experiences they're never going to forget. And what a miss not to really lean into this and make the robots fun and cute. And then as a result, something that society has an easier time accepting, because again, we talked about the value proposition. I really believe that these are important for cities to kind of, again, make cities better, make them more pedestrian friendly, make them safer for everybody, and of course, give that benefit to the restaurants and local merchants. So, but we have to make something that people want to adopt. And so the robots have eyes, they have names, they're cute,
Yeah.
they're polite. All of that is part of it. And by the way, you helping a robot probably also helps you maybe fear the robot less, because know that this is something that kind of collaborates with you.
Yeah, I thought it was quite nice actually that it asked me to help it. I don't know, it felt interesting, and I did it. There was nothing to lose from it. I was like, all right, I'll click the button. You know. Yeah. Physical AI is an area that I personally like a lot. It's an area that you're really in. Um, I think it gets overlooked a lot, physical AI. I mean, there's so much happening in the software space. It's easier, I guess, to scale to millions of people in the software world. Why do you like physical AI and building in the physical AI space?
I mean, because B2B SaaS is just,
Yeah.
it's only going to take you so far at the end of the day, right? Like, at the end, I think every time we have a new kind of paradigm shift in computing, whether it was first was just creating the processing units and therefore the computer, so we can do math faster or run on a spreadsheet, and then we connected everything together. That was a big step. And then we made them smaller so it fits in our pocket, and now we are making them smarter. So every one of these paradigm shifts, I think it starts with impacting our digital lives first, but
Mhm.
eventually it's going to impact our physical lives. And I think that's where the biggest opportunity ultimately lies. So it is much harder, absolutely, but it's also a lot more fun, and I feel like the impact of it is just so meaningful. Like, think about how cities changed because of cars. That was like a physical technology that came in. The engine really kind of started all that. We're looking at that kind of magnitude change, and I feel like I'm so fortunate to be sitting at this moment of time working on something that is going to have that kind of impact on society and how we live our lives and how our cities look and feel. So I don't know, it's hard to not get excited about physical kind of AI or physical anything like robotics.
Yeah, I agree. I like to make stuff and then, it's there in this reality. Like it's something real. You can touch it, you can feel it. It's quite exciting. And like you mentioned, the disruption opportunities are a lot. Especially, I think there's less competition too, in general, because it's just the barrier is higher. Um, when you think about like building, like just like scaling this in general, like do you see different types of robots being needed for different applications? Because I know you have like one primary one now that's used on sidewalks. Have you kind of thought a lot about that, or is there not really much of a need because the current version serves pretty much most areas?
No, I mean, this is just the first form factor basically, and every generation of the robot is going to be more capable, but there's then going to be all sorts of more customized or more generalized. Actually, you may want a robot that can do more things when the
Mm,
frequency of that work is less than the initial applications. I think there's going to be robots in every human environment that
yeah,
we have, right? Like you have your maybe vacuum cleaner today at home, which even that has a lot of limitations today, and there's a lot of room for innovation. But there's so much more that we could have robots assist us with, and we partly are blocked by the fact that robots have a hard time navigating our 3D environment and coexisting with us in a way that's not disruptive to us, and they're actually successfully and reliably able to accomplish their mission. So that's the problem ultimately we are solving. Because if you get robots moving around sidewalks in major cities, I think you've solved one of the most complex environments. And bringing those robots to other places, even if their shape and size and kind of physical capabilities changes, the brain behind it is largely the same. I think that opens up a long tail of use cases that I'm very excited to see this platform kind of adopted to.
yeah, yeah. It's quite exciting. Um, just thinking about like the scale of this and how much you've already scaled so far, has being a public company been helpful for that at all? Is it like, why did you want to be a public company in general, and what do you think you even need, I mean, to get to this next phase of scale? Is it a capital problem, or is it just cities being okay with it? Like, what is the bottleneck?
Yeah, so this is my maybe fourth company
Yeah.
that I've helped start. So one thing you realize is the innovation cycle or life cycle and the capital life cycle are not always a match. So
Mm,
investors in the private market, they get excited about something for a couple of years, then they move on.
yeah,
And your job as a founder is to last something like 10 years before you get to a place where you're off and on your own feet. So how are you going to bridge that gap? And different people find different solutions. I wouldn't say every solution is the same. If you're very fortunate, maybe you can do that in the private capital markets and get yourself to the destination. But sometimes you have to look outside and see how to solve that mismatch in the life cycles of private money versus startups. In our case, we went public in the worst year to go public, basically, in terms of the number of IPOs. But it was also a really, difficult year in the private side. With I know many companies in our space, in the autonomy space, that started roughly the same year as 2017. And they didn't make it. Some of them were inside bigger companies, like Amazon had an effort with sidewalk robots, for example. Google had a robotics team that they shut down. So it didn't matter if you were part of a big company or you were an independent private company. It was a tough market. So our thinking was we should try to access the largest pool of capital, because some people are going to understand this and others don't. And we don't need everybody to believe in this. We just need those few who really get the vision. And when you're in the public markets, you get access to all investors rather than just the private investors. So it was a bet. It took us a year to kind of go through the process, and we wouldn't have known until the end of the process whether the bet paid off. Obviously, it really paid off in this case. I'm not sure if it always would, but we got fortunate and we got to that result. But I would tell you one more thing. I always wondered about this long before we decided to go public, which is we're going to new cities, and there are merchants, there are people who are gonna interact with our robots. How do we make sure or try to help them have part of the upside of what we are building here, other than obviously the economic value to those merchants and customers? And so this idea of being a public company, so that more of the communities that we are going to be part of have an opportunity to join this ride and join this vision, was very compelling from basically when we first became an independent company by spinning out of Uber back in 2021. So it was something I talked to our head of comms almost as soon as she joined. I'm like, look, I think we need to go there, but I don't know how. It sounds kind of crazy, but it's something that's in the back of my mind. So when the opportunity came for going public, it was already something that we were thinking is a good solution to solving the broader problem of going to communities and benefiting people in a more meaningful way.
Mhm. Yeah, well, Ali, I appreciate taking the time and doing this. That was all the questions that I had. I think it's amazing what you've been able to build here and how you've created this autonomous network that is, I think, the most advanced real world use case autonomous system, fully autonomous system in many cases that there is. And it's changing the way delivery works in general. It's having that type of effect that you mentioned before, and I'm just excited to see it continue to scale and thousands of more of these robots out there and what's to come next. Thanks for coming on.
Thank you so much for having me.